For Protastructure column detail drawing, the column, it does not represent its column just like the way we are representing it in AutoCAD. Okay, it breaks every floor. Now, let me show you something. Here you can see 1C30. I'm going to cycle this 1C30. Just relax. Let me explain something. This is 1C30. It means story 1. This is 1C30 is for story 1. All right, I know what to do. I'm going to come back to this column, elevation, story 1. I'm going to draw okay. All right. All right. So this is my column. This is one area of column that a lot of people do not have insight about. You can see Protadetail can give you your column continuously. I just discovered this not quite long. You can see this from here now. You can see it's telling you plus or minus 0.00. It's telling you that this is from here now downward is our foundation level. Okay, so you can now, this is as story as foundation level. This thickness now, this depth here is around my footing. This line that you see, I think this is a green color. This line is representing your links. Okay, this dark line is showing you, I'm talking about from the foundation level now. This other one that is black, this black line, that is the main longitudinal reinforcement. That is, it is Y16. While this link, let me confirm what the link is. The link is Y10, okay, at 175. So these are the links, Y10, Y10, Y10 at 175. If it is drawn to scale, by the time you measure, it's supposed to even give you 175. Dimension, vertical dimension, here. Okay, this is not drawn to scale. But if it is drawn to scale, we are going to see it 175. Okay, so the span from this link to this link is 175. From this link to this link is another 175, like that continuously. So this is the foundation level showing you 0.00. This is the first floor level. Okay, this is the normal ground level. This is normal ground level, ground floor. That is what Protadetail calls story 1. Okay, it is the ground floor. While you can see showing you an indication that this is a beam from here to here. This is a beam. Okay, so after that you have another column going until it hits another beam here. At this level now, this is the roof level. Okay, so the black lines are actually the column lines, sorry, the longitudinal reinforcement, while this one is actually the links. Okay, it's the same thing with what I was explaining in the AutoCAD detail drawing. There is no single difference. The only thing is that the way Prota structure will represent its detailing is different from the way when you want to do your detailing in AutoCAD. You can see Protadetail is giving you all the links, drawing all the links 1, 1, 1, 1, 1, 1 until it gets to the end here. But when you are doing it with AutoCAD, you can just use one line to represent the entire link instead of showing all the lines. So it depends. You and I, our detailing can never be the same, except if you learn detailing from me, you may want to adopt the way I do my detailing. So when you have 2 people or 3 people, 3 different draftsmen who learn detailing separately, they cannot come up with their detailing the same, but their detailing can be 100% correct. But the way you represent your own may be different from the way I represent mine. So that is why I said Prota structure detailing is perfectly correct. There is nothing wrong with it, okay? It's just different from the way it is being represented. We will represent our detailing here in Nigeria, okay? But you can see, showing you these 2 lines, these are 2 reinforcement. Is the reinforcement is the same thing with what I have here in my normal AutoCAD detail drawing. It's the same thing. It's just the representation is different. This is the 2 line. When you cut, this is just a cross section. When you cut, you are only going to see 2. But when you are looking at it from a plan view, you are going to see it like this. 4 reinforcement, 1, 2, 3, 4, because this is 4x16 on a 230 by 230 size of column. So when you look at the one we did in AutoCAD, there is no, the only difference is just in the representation, but it's the same column that we are talking about. Look at this now. I'm just representing this reinforcement and this, telling you that I have this, what I have here is exactly what I also have here. And it is 4. I have 4 of it. That's why when you come to the cross section, you are going to see 1, 2, 3, 4. The same thing with what I have in my Prota detail. This longitudinal reinforcement is the same thing as what I have there. Okay. Now here we are showing that, okay, we have 16x10, okay, at the spacing of 200. So here I can change this to be, okay, I will just divide by the height. If it is 3 meters, for example, 3,000 divided by 175. If I want to use the same spacing that was used in the Prota detail, all I need to do is just to divide the height. If I divide it, that's the length. If I divide it by 175, it's just a simple calculation you do in your calculator. And then you just type in the value here. And then here you type in the spacing, 175 instead of 200 that is written here. So it's the same thing. There is no difference. Here I told you this is the foundation level. This is this is the base. Here is actually the normal one we call the German floor. Then here we have the floor level. You can see from here to here is the thickness of the beam. Then here is indicating the slab that continues this way. This continues this way. It's the same thing with what we have there in the Prota detail. So there is no single difference. The only thing is just the way that it is represented. So even me right now, if I find myself in a particular consultancy, not where I was trained, they may have a different way of how they represent their detailing. And I don't have a choice. I must maybe have to adopt to the way they represent their detailed drawings. So everybody with the way they represent their detailing. Okay. So, but there are some basic informations that you need to understand. So once you understand that there is nothing wrong with representing or presenting your detailing as it is right now from the Prota detail software. Okay, so you can see it's showing you at this point here now how you have your overlap. This is the reinforcement coming from the foundation level. You have this one is at the normal floor level, and then it overlaps at this point here. We also have that overlapping there on the other one. Okay, so it's the same thing. So it depends on how you actually want to represent. And then there are different patterns of actually representing your detailing drawings. But there are standards too, there are rules that you must follow. That is why I was emphasizing on you laying your hands on that simplified reinforced concrete design book by Victor Oyenuga. So the column is actually very, it's one structural member that is not even difficult to actually interpret. The only another structural member I know you may have a little challenge is when you come to the case of your beam. Okay, so when it comes to beam here, you can see here we have this is beam 1. Sorry, let me just bring out a beam from here directly. Come to story 1. Let me bring out a very small beam so that it will not be complicated to explain. Now you can see this beam here now. This is the span 1,230. This is one beam 31. You can actually view that in your plan view here at your slab and beam layout. This is one beam 35. So we have not actually gotten to beam. Beam is a bit deep too. In order for me to start explaining this, we are definitely going to come to this. But then you can trace this 1B31. All you need to do is to trace it from the floor plan, from your slab and beam layout. 1B31. 1B31. Look for 1B31. Where do I find this 1B31? 1B31. This is 44, 40, 36. I think it should be here. 1B31. Okay, this is it. This is the beam. So if you look at from here to this place, this span from here, you can see this beam now is exactly what we are looking at there. This entire beam, it comes from here now to this place. Okay, that is the beam there. So let me copy this and take it there. Look at this beam. If you check this span from here to here now, is what we have from here to here. So let's see if it's drawn to scale. Definitely we are going to have that value the same with this. 1230. 1230. If you measure here also vertical here, 3975. Okay, sorry, that's a mistake. I didn't pick that well, but this is approximately 4,000 anyway. Let me take it again. I think I didn't pick it well. Here too. Okay, exactly. So you can see this is 4,000. This one is also 4,000. That's 4 meters. Okay. So if you look at this now, it has a reinforcement inside of it. The span from here to here now is 4,000. The span from here to here now is 1,230. Okay. Explaining the reinforcement is actually deep also, which we are going to get into that. So I'm going to be explaining that as we progress in our structural detailing class. So right now, if I'm to start explaining beam detailing is a bit deep and it's a bit wide. So, but then this reinforcement, you can see we have this reinforcement at the top here. We have the compression zone and then at the tensile zone, okay, which I'm also going to be explaining all of that. But if you check this depth now, from where you have this reinforcement to where you have this other reinforcement is 350. But if you include plus the concrete cover, it's going to give you 450 because it has a cover. Okay, then you have now it's showing you that there is a part of this beam that actually enters the slab. That is why you are having it in this shape. So if you measure from here now to here, because your beam and your slab are casted monolithically, so by the time you cut a cross section of that, you're going to see it in this shape, because the beam and then the column are actually attached to each other. So you are going to see this slab. This one is showing you the shape of a slab. Okay. So this other one from here now to here is the entire depth of that particular beam. And then the reinforcement you have inside, 1, 2, 3, 4, is the number of reinforcement that is provided here. Here we have 2y16. At the bottom, we also have 2y16. So if you plus 2 plus 2, it's actually going to give you 4. So at the top, you have 2 reinforcement. At the bottom, you also have 2 reinforcement. So that is just it. And then the entire length here now, from here to here now, I have just 10 minutes time for this to actually end. But if you check this now, from here to here now, that's around 5,230. So this entire reinforcement spans from here now to this place. I'm going to explain all of this as we progress in our AutoCAD detailing, because we've not gotten to our beam yet. So by the time we get to our beam, definitely this is going to be a piece of cake. You are definitely going to understand it 100%. And then this Y10 300 that is showing you is telling you the number of links. Is telling you you have Y10 as the thickness of that link, and then the spacing of that link is actually 300 at this span from here to here, and also from here to here. Now this span is also another 300 spacing. So the spacing is in 300 spacing, and then the thickness of that reinforcement is Y10. That is just what it's telling you here now. So that is that. It's very, very simple. And then here, I notice there is this software has some little lapses here when it comes to showing this link. I don't know why, but if you have that, if you know the reason why it's not showing this, I will gladly appreciate to learn. This link is supposed to come this way, you know, you have these. So it's supposed to come something like this. It's supposed to show you the links. In the cross section, you are supposed to see the link. So you are supposed to see the link like this. So this will be the link that is actually wrapping the entire reinforcement. Okay. So this is the link. This is how it's supposed to be seen in the cross section. So this is the cross section of this beam. By the time you cut here, this is what you are going to see. So the software actually made the two cross section in this place. So you are basically having the same thing. So what you have here is basically what you have here. So it's the same. So around here, and then when you are looking at this direction, you can see like an arrow here pointing this direction. So when you are looking at this direction, this is definitely what you are going to have. And then if you look at this beam now, if I take like a little cycle of this beam, you will discover that you are having like a shape of an L. So that is what you have here, which is an L shape, an L shape. We have T beam, we have L beam. Okay. So this is actually an L beam. Okay. So that is it. So there is nothing that difficult about or a bit different, nothing really different from the detailing we have here and what we have in the AutoCAD detailing manually. because the only thing is that, like I said, the way the software may want to represent its detailing may be a bit different, a little, there will be a slight changes. But I think in Nigeria here, our beam detailing is not very far from what Protastructure always gives us. Okay, it's not very far. It's not very far. I think there is a lot of similarities when it comes to beam, most especially, because if you check this beam here now, it's very, very similar to what I have there in my Protadetail. So you have your links here at Y10, it's 200 spacing here. I have the top reinforcement, I have the bottom, and then I have the cross section of that particular beam. Okay, so that is that. It's very, very simple. This section will soon actually be over. So I just have like 5 minutes time for this section to actually be over. So whatever we are doing in the AutoCAD detailing is definitely not far from what the Protastructure is going to give us. And then with that knowledge, you can be able to interpret detailed drawing, structural detail drawing that has to do with building properly. Okay, so there's nothing that difficult or a bit or different with what we have here. Only that sometimes the Protadetail will give more information at some particular area, while sometimes when we are doing it manual, we tend to give more information or more detail to a particular member most times. Okay, but sometimes the Protadetail will even give more detail on some particular structural members. Most especially beam. I think this software has actually done a very great job on its beam detailing. The beam detailing, I think the software has done a very great job when it comes to its beam detailing. So we are going to go into all of this much more deeper, most especially the beam when we are focusing on beam detailing. We'll go deeper into that in AutoCAD, and with the knowledge of the one we are going to do in AutoCAD, by the grace of God, you will be able to interpret any other beam detailing, whether from Prota, whether from StatPro, or whatever software that will generate your detailed drawings for you.